Hello, my friends. Today we will be working with Bayes' theorem. The objective is to solve a problem using Bayes' theorem and the methodology 1. Decision tree 2. Bayesian calculator 3. Join, conditional, and marginal probabilities. The problem is called Peacekeeping, and it was taken from Dan Morris' book published in 2018, Bayes' theorem, a visual introduction for beginners. And it says, you are a soldier on a peacekeeping mission overseas and were recently caught in a surprise attack, pigeonholing you on a narrow street. A rebel truck had appeared and was making its way towards you, but it all of a sudden turned and disappeared. Now, with a threat gun, you begin to walk down the dusty street and turn a corner only to quickly turn back. 5 men are 100 yards down the street and holding rifles. You peek your head around the corner once more to get a better look. Are they rebels? Are they part of the coalition? You radio HQ and are told based off of local intel that the men are likely rebels. You crouch against the wall as you think about what to do. There are roughly 100 rebels in the city and 75 coalition troops. Local intel is not always reliable. In your experience, it correctly predicts rebels 65% of the time. Intel has been sketchy lately and has incorrectly predicted men as rebels when they're not rebels 15% of the time. We want to know the probability that the soldiers are rebels given that Intel says they are. To solve this problem, let's highlight the information that is important in this problem. This is the information. And let's begin with the first sentence. There are roughly 100 rebels in the city and 75 coalition troops. To calculate the share of rebels, we just divide 100 over 175 to get 0.5714. To calculate the share of not rebels or coalition troops, we divide 75 over 175 to get 0.4285. Now we use the decision tree. The decision tree has two arrows, yes or not. And the upper arrow divides itself also into yes or no to get a yes, yes, step 1, and a yes, no, step 2. The bottom arrow also divides into a no, yes, step 3, and a no, no, step 4. To fill in the first two arrows, we have to think of rebels share, which is 0.57, and not rebels or coalition, which is 0.43. So this looks like this. And to fill out the second arrow, we based on the information written in the second sentence that says local intel is not always reliable. In your experience, it correctly predicts rebels 65% of the time. So yes predict equals 0.65. And we just multiply 0.57 times 0.65 to get a yes, yes of 0.3705, which is step 1. And if we subtract 1 minus 0.65, we get the yes, no version. We multiply 0.57 times 0.35, and we get against the yes, no version of 0.01995, which is step 2. We continue with the bottom arrow, and we take the information of the third sentence that says Intel has been sketchy lately and has incorrectly predicted men as rebels when they're not rebels 15% of the time. So this is 0.15. So we also multiplied the no yes version, 0.43 times 0.15, and we get 0.0645, step 3. Again, if we subtract 1 minus 0.15, we get 0.85. The no version is 0.43 times 0.85, which equals 0.3655, step 4. Now we highlight the numbers that we need to use the Bayesian calculator. We go to the Bayesian calculator and we fill the empty spaces with the numbers we have highlighted. The first one is 0.57. 0.57. Second is 0.65. 0.65. And the third is 0.15. 0.15. Compute, and we get the result we are looking for. This is 0.8517, or 85.2%. The Bayesian calculator can be found in this link, and it's available in the web. So we continue with the decision tree. And as you can see, the decision tree has a formula. And it says divide step 1 over step 1 plus step 3. Step 1 is the yes version, step 1, 0.3705, which comes also in the denominator, and we add step 3, which is no yes, 0.0645. And if we add these two numbers, we get 0.35. And if we divide 0.3705 over 0.435, we get also the result, which is 0.8515, or roughly 85.2%. Once we found the answer using these two methods, we continue with the third method, which is using joint conditional and marginal probabilities. And to do that, we use this matrix. This is a 2 times 2 matrix. We have two columns, C as yes predict and Z bar no predict, and two rows, R rebel, which is something that we already know, 0.5714, and R bar not rebel, 0.4285. And according to this sentence, local intel is not always reliable. In your experience, it correctly predicts rebel 65% of the time. We use the conditional probability that says the probability of C given R equals the joint probability of C and R over the marginal probability of R. Now the marginal probability of R is 0.5714. And the one we are using here is 0.65. So we just need to find the joint probability of C and R, which can be calculated by multiplying 0.65 times 0.5714, which is 0.37141, and we plug this number into our matrix. So we continue, and if we subtract 0.5714 minus 0.37141, we get 0.1999. So we continue with the sentence that says predicted men as rebels when they're not rebels 15% of the time. So this could be translated into a conditional probability that says The probability of C given R bar equals the joint probability of C and R bar over the probability of R bar, or as we can read here in the sentence, the probability of Intel predicting that a soldier is a rebel when he is not. Well, this is 15%, and the denominator is also familiar to us. This is 0.4285. To get the joint probability, we just need to multiply 0.15 times 0.4285, which is 0.064275, and we plug the number in our matrix. Now with these numbers, we can complete our matrix because we know a matrix like that adds up to 1, either if we sum the columns or the rows. So our final matrix would look like that. Once we have all numbers, we can come back to the main question. We want to know the probability that the soldiers are rebels given that Intel says they are. This could be solved using the conditional probability of the probability of R given Z equals the joint probability of R and Z over the probability of C. The joint probability of R and Z is this one, 0.37141, and the marginal probability of C is 0.43568. And if we divide, we make the division 0.3714 over 0.4356, we get the answer 0.852 or 85.2%. So we read the conclusion drawn by Mr. Morris that says at first you had minimal confidence in what Intel told you, but now you see that the probability of the soldiers being rebels, given that the Intel says they are, is 80%, 85%. This completely changes your outlook and forces you to turn back and wait for the remainder of your team to arrive. If the group are rebels, you don't want to approach them alone. So, if you found this video helpful, please give me a like and thank you for watching. Until the next time. Bye.